So basically, it means we have 15 different ways by which we can, arrange these two electrons, all right, into their subshells, all right. There are 15 number of ways, all right. And you know that p orbital, like I said, it's a subshell that has 3 different rooms, all right, 3 different rooms. But we have 2 electrons, and there are different orientations the electrons can take. The electron can go, clockwise. The 2 can be clockwise. One can be clockwise, the other is anti-clockwise. The 2 can be paired or not. So to give us the full picture is what you use the microstates table for. Since these houses or rooms are labeled +1, this is a p orbital. S, P, D, F. Alright, the L value is 0, 1, 2, 3. Therefore, the L value for P is 1. Therefore, ML is -1, is 0 plus 1. So if ML is -1, is 0 plus 1. On this side, you have the number of ways on this side to put your ML. And the ML is what? -1 is 0 plus 1. Alright? So -1 is 0 and plus 1. Alright? There are 2 electrons. This is the first possibility. Alright? Like we said, like we have known from the rules guiding electronic configuration, Hund's rule of maximum multiplicity, you fill simply before pairing. So there are 2 electrons. This is their houses for case 1. For case 1, this is their rooms. Room 1, room 2, room 3. For case 2, room 1. So let's assume we are filling the electrons. Let's assume they are facing upward in the first case. Since we have 2 electrons, the 2 electrons can occupy these 2 rooms. For case 31. For case 32, 1 electron can be here, the second one is here. For case 33, 1 here, 1 here, 1 here. There are not 2 ways that can be exactly similar. Alright? They can never be similar. Pauli's exclusion principle. Not the 2 electrons can never, 2 or more electrons can never have the same 4 quantum numbers. In this case, it still applies. Either of these, each one of these 15 ways cannot be similar to another. Any one of these 15 cases can never ever be similar to another. Alright? So this is case 1, up, 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 up. Then up, down, up, down, up, down, up, up. Cases up, up. We are done with up, up, simply. Up, down, up, down, up, down. We're done with such a possibility. Then down, 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 down. Of course, when we have up and up, if we have up and down, 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 then we can still have down and up. The first one is pointing downwards, upward, downward, upward, downward, upward. We are done with filling singly. Then we can now pair. When they are paired in the same room. When they are paired in the same room. Alright? This is to tell you also that the real life example, you are exposed to 3 bedrooms and you are 2 in number in the house. There are 15 number of ways you can decide to sleep in those rooms. It means that in 15 days, you may decide not to repeat the same sleeping pattern if you are security conscious. Alright? So, we got this. When you get this, we are trying to look at the, what do you call it? The question says that spectroscopic terms, and like I told you, spectroscopic terms are more or less the what? Are more or less the subsidiary terms. Quantum number, subsidiary, but in capital letter. So once you are done with this, what else? You look for the summation ML, summation MS. Alright? Why? This is simply because you want to plot MS against ML. Right? You want to plot MS against ML. So you must find the summation. Right? So how do we do that? You know, L is what? Is a subsidiary number. In this case, it is 1. Alright? 1. The number, you know, like you have 1 electron. Electron is equal to 1. L is equal to 1. So, how many, and when we say summation, it means that you are adding the L together. Alright? Minus 1 times 1. Or how many of these do we have in 1? But when you are multiplying it by 0, what do you have? 0. That is minus 1 times 1 plus 0 times 1. That gives you minus 1. So this is minus 1. Minus 1 times 1, minus 1 plus 1. Minus 1 plus 1, 0. Is 0 plus 1. Minus 1 is 0. Minus 1 plus 1. Is 0 plus 1 plus 1. Alright? Minus 1 plus 0 minus 1. Minus 1 times 1 minus 1 plus 1 is 0 plus 1 minus 1. Alright? Is 0 plus 1. Alright? There are 2 of these electrons multiplied by minus 1, minus 2. 2 of these electrons multiplied by 0 is 0. 2 of these electrons multiplied by 1 plus 2. That's summation ML. Adding the ML together for each possibility. Right? Summation MS. You and I know that MS is the, you know, angular spin. Alright? The spin. So adding them together, you know, whenever an electron is facing up, from our basic chemistry, it's plus half. When it is down, it's minus half. So it means that these two are facing up. That is half plus half. That is 1. 1. Alright? Plus 1. Half plus half. 1 plus 1. Alright? Spin has to do with their directions. Magnetic has to do with their quantity. And then multiply by their coefficients. Alright? So these two are facing up to plus 1. 1 up, 1 down. That's plus half minus half. That is plus half minus half. Plus half minus half. Alright? It's just like 1 minus 1. That is what? Is 0. Up, down, is 0. Up, down, is 0. Down, down. Minus half. That's minus 1. Down, down. Minus 1. Minus 1. 0. 0. 0. 0. 0. 0. I hope that is clear. Alright? Then we are now going to translate this. We've gotten to a stage here. You have the summation ML, you have the summation MS. Now you translate this onto this table. Right? Onto this table. MS is up, ML is coming down. You know, you can say this one so as not to confuse yourself. For example, on an example, S is for sleeping. When you are sleeping, you lie horizontally. L is for, you know, when you are limping, you are standing. You have to stand before you can limp. Alright? So those ones are in vertical order. Now, the MS, what are the range? For the MS, we have minus 1, we have 0, and we have plus 1. So those are the things we are going to be listing. Minus 1, 0, plus 1. Are we there? For the ML, what is the range? We have minus 2, right? We have minus 1, we have 0, we have plus 1, we have plus 2. So we are going to be listing them. Minus 2, minus 1, minus 2, minus 1, 0, plus 1, plus 2. Right? Okay. Now we are going to be mapping. Alright? We are going to be, checking where they meet. So that we don't waste our time. For minus 1, we have, let's start on what we have there. We have minus 2. We can pair minus 2 against minus 1. Minus 2 against 0. Minus 2 against plus 1. So minus 2 against minus 1. Do we have it? We have only one minus 2. And it is against 0. So we can pick it like this. Minus 2 against 0. With one symbol. Right? So we have minus 1. We have minus 1. Let's count minus 1 against minus 1. Let's look at this. Minus 1 against minus 1. Minus 1 against minus 1. We have this. That's 1. In fact, we only have 1. Minus 1 against minus 1. Minus 1 against 0. Minus 1 against 0, we have this. Alright? We have this. Minus 1 against 0. Minus 1 against 0. Alright? The second one has to be another sign. So that you can classify it properly. We have minus 1 against plus 1. Yes. We have minus 1 against plus 1. Just 1. Minus 1 against plus 1. 0 against minus 1. 0 against minus 1. And that's all. 0 against minus 1. 0 against 0. 0 against 0. We have 1. We have 2. We have 3. 0 against 0. We have 1. We have 2. Look for any other symbol. Let's use triangle. We have 3. 0 against plus 1. We have 1. We have only 1. 0 against plus 1. We have only 1. 1 against minus 1. 1 against minus 1. We have 1. We only have 1. 1 against minus 1. 1 against 0. 1 against 0. We have 1. We have 2. 1 against 0. We have 1. We have 2. 1 against 1. We have 1. Alright? And that's all. 1 against 1. We have 1. 1 against 1. We have 1. Then 2 against minus 1. In fact, we only have 1 plus 2. And it is against 0. 2 plus 2 is against 0. All of these points that we've mapped together, since we have 15 possible number of ways, has to give us 15. Otherwise, there's something we have missed behind. Alright? Now if you check it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Alright? Those are the 15 number of possible ways. Now we classify them. To classify them, we take the ones that are similar. We take the ones that are similar. We can call this class A. We can call this class B. We can call the one of cross class C. The one of triangle, one-man battalion, class D. And this last one, class E. For class A, we have to show, the L, the range is from -1 to +1. -1, 0, +1. Alright? That's what orbital. Of course, when you have a magnetic to be this, S is 0, P is 1, and that one is -1, 0, +1. D is 2, and that 2 is -2, -1, 0, +1, +2, and so on and so forth. So A is -1 to +1, which is what? Which is a P orbital, or a P. This is where you extract out your what? Your spectroscopic term, capital letter P, because this is the range. For B is from -2, -1, 0, +1, +2, and that is what? Alright? That is G. For C, we only have 3. That is -1, 0, +1. That is another P. For D, we have just 1. No. Yes, just 1. That is S. S, capital letter. For E, -1 to +1. That is P. Invariably, the spectroscopic term that we are looking for is then how many P? We have 1, 2, 3. The multiplicity, the number of times it appears, 3P. How many D? 1D. How many S? 1S. So that is our answer. That's the number of those are the various spectroscopic terms that can be formed for this configuration.